Okay, so the piece of paper that you are sharing, I need you to fold it in half this way. Fold it in half this way and then tear it. Yeah, please don't lick it. There's scissors on your desk, so you don't have to lick it. I guess it's a good source of fiber for you. Cut it if you wish, tear it if you wish. Okay, is everybody with me now? Not yet? Okay, this needs to be as straight as possible. Okay. Did I remind you that I was recording this? Okay. Okay, so is everybody with me yet? Needs to be as straight as possible. Okay, so now each one of you have a piece of paper that's this size, right? Okay, so each one of you fold yours in half and tear it again, or cut it again. The same halfways. Okay? Yep. We're not making a spinner. There, that'll help. Okay, so does everyone now have 3 pieces of paper? These 2 smaller ones that we just tore, and then their big regular size one. Okay, put the 2 smaller ones aside. And we're just looking at the big one now. Okay? Same way that we folded the last one, we're going to fold this one. Okay? But we're not going to tear it. We're only going to fold it. No tearing. Okay? So I have it folded in half like this, right? So now I'm going to fold this one this way. So it looks like that. I'm sorry. Yeah. So now I have a fold here, and now I'm going to also have a fold here. Yeah, just fold it to the middle. Both sides, so that if you looked at it on the end, it would look like an M. Okay, it might look like a W. Does it look like a W? That'll work. That'll work. But see, here's what I want you to do. Okay? Here's what I want you to do. I want you to fold them all the other way now. So that they've been folded both directions. Do you see that? It's still an M or a W, but all the folds are different. The other direction from what you started with. Okay? Okay, so does yours make an M or a W?
Yes, ma'am. Yeah.
Is everyone with me?
Yes, ma'am.
Got it? Okay. Now, like that. Make sure you folded it the other way a couple times so that it folds both ways really easily. Okay? Now, don't let this be a tricky part. Okay? So everybody watch. Watch. I have mine folded like an M right now, right? I'm going to take this middle part and put it together. And I'm going to turn it sideways. When I turn it sideways, I'm going to find the middle approximately and cut all the way to the fold. See how I cut all the way to the fold? I didn't go all the way to the edge of the paper. I just went to the fold. You okay with that? Awesome. Now, also, I need you to cut that middle, and I need you to cut that middle. They should all have scissors, but thank you. Everybody see? So when I open it up, I have this middle section that have these cuts in it. Do you see that? Okay. Now I'm going to take one of my skinny parts. I'm going to weave it. And then I'm going to take the other one and weave it the other way. So yours should look something like this now. Perfect. Now, the first time I did this, it kind of blew my mind. Are you guys to this part yet? No, I haven't told you the part that blows your mind yet. Hold on. Are you to this part right here? Okay. If you're to this part right here, I want you to fold it so that it's like a book. Okay? So you have it folded like a book? So you have, if I open it back up again, I have a front and a back, right? So I should have 1, 2, 3, 4 of these sections, right? Of the weaved sections. So watch when I open like a book. If I open this, I've got this one, and then I've got this one, and I've got this one, and then I've got the back. Yeah, it does. So you go, I'm like a book. So 1, 2, 3. It's magic. Thank you. Well, first of all, open it like a book. So it opens like this way, right? Open it this way. And then open that middle part. And then open the last part. But then we also have the back. So what's funny is that when you have it like this, especially when it's open to the middle part, it doesn't look like there's a back. But when you pull this open, there is a back. So if I open it and all the pages right here, it doesn't look, if I have it open to the middle, it doesn't look like I have a back. But when I pull it this way, I do have a back. Okay? Okay, so this is what's called a foldable because we folded some paper to get it here. Okay? So we're going to make a folder. What are we making our foldable today about? Transformations. Transformations. So the first thing I'm going to do is put the title on the front, and then I'm going to flip it over. Or whatever you want to put. You can put your whole name. You can make it really small in the corner. I just made mine really big across the back. Okay? The front it just says transformations. The back it says my name. Okay? Are you okay so far? Okay. So think about the transformations we talked about last week. And let's start with this transformation. All I did was open the front cover and I'm here. Are you with me? Okay. So let's start here. Y equals negative f of x. Now, let me be clear about something. You see I have this piece of white paper? If I don't have it, it's real shiny and it's hard to read. So if I have a piece of white paper here, then you can read mine a lot easier. So that's why I have that paper behind it, okay? And I'm going to zoom in a little bit to help out with you being able to see. Okay? So I have y equals negative f of x. It is. But this is whatever function I have. This is just a general function. Okay? So we're saying y equals my function. Okay? Now, if I have a negative of my function, if the negative is on the outside, what happens? It is a reflection. So what kind of a change is that? It's changing this way. So it is a vertical change, first of all. Okay. So you see how we have four different sections here on our foldable? So we're going to fill each one of these sections up. Okay. So this is what kind of a change it is. And this is more specific. What's the more specific? What actual kind of change is it? It's a reflection. Over what? X-axis. Okay. So this last one, the bottom section is going to be graphs, examples. Okay. So if I have y equals 2 to the x power, and then my second example, my change is negative 2 to the x power. Can I graph both of those based on what I know about parent functions and based on what I know about transformations? Can I do that? Okay, so what does my parent function look like? Starts here and goes like that. Remember that? Okay. So what does the negative in front cause it to do? Reflect over the x-axis. So instead of being on top of the x-axis and rising, it's going to be under and falling, sinking. That's fine. It's just reflecting. It's like a mirror image across the x-axis. You okay with that? Okay. Now, to keep things clear, I want to go ahead and go all the way to the back. I don't want to be in this middle section right now, not yet. I want to go all the way to this back section. Okay, so it only has one weaved part right here. Okay, and we're going to call this y equals f of negative x. Now, did you see why I wanted to go all the way to the back?
Yes.
Okay. What kind of a change is this?
Horizontal.
How do you know that?
Because it's inside.
Good. This is a horizontal change. What kind of specific horizontal change is it? Yeah, what's another way to say that? Reflection over the y-axis. It is a horizontal reflection. It's going this way, horizontally, right? So that's going to reflect it over the y-axis. So let's use the function, the square root of x. And then let's use the function, the square root of negative x. That's what we're talking about here right now, right? When we put the x inside the function. See how the x is inside the function? Okay. So what's the parent function look like? Starts at the origin and goes where? Like that? Okay, so if it reflects across the y-axis, where does it start? Still at the origin, and then goes where? To the left. Like that? Are you woeing me as if I was a horse? I feel like I should go. Okay, so we've taken care of both of the negative signs. If the negative sign is outside the function, if the negative sign is inside the function, those both cause reflections, right? So let's open it to the middle now. Zoom out just a little bit so you can see I'm in the middle. Okay, I'm in the middle. So let's try this one. Y equals f of x, whatever function I had, plus k. And then y equals, you guys are talking while I am, that's rude. Please stop. Now, to address some concerns I had earlier today, is this allowed to be minus k?
Yes.
Is this allowed to be plus h?
Yes.
Yes, but this is the original formulas that we were given, isn't it?
Yeah.
Okay, so that's why I wrote those two specific signs like that. Okay? So, where is the k in relation to the function? Outside. So what kind of change is it? Well, now, we can get a little bit more specific this time, can't we?
Vertical shift.
Vertical shift. And what's important to remember in that word? The F. Good. Remember your F. Okay. Now, do you want to do the whole column about K and vertical stuff, or do you want to do rows at a time? Do rows? Is everybody okay with that? Okay. So if this causes a vertical shift, what does the H cause? Horizontal shift. Now, what direction is vertical? What directions can you move vertical? Up and down, right? Okay. So what is going to cause this function to move up? Okay, which one is going to cause it to move up? So a positive k will cause it to move up. So what's going to cause it to move down? Negative k is going to cause it to move down. Okay. What direction can we move horizontally? Left and right. So if this says x minus h, what direction are we moving? Right. Okay. And if it's x plus h, we're moving left. Remember, this h is a positive because that negative is part of the formula. This h is negative because it's x minus is part of the formula, so it would have to be a negative h. That's why we're moving right here and left here. Okay? You got that? Okay, let's add some example graphs. Let's say f of x equals the absolute value of x, and then f of x equals the absolute value of x plus 2. So this first function, what's the parent function of absolute value look like? A v. Where is this one going to move?
Up to.
What part of the absolute value moves up to?
The origin.
Only the origin?
The point of the v.
So yeah, that's the easiest point to move, but what point along the absolute value function moves up to? All of them, right? Every single point moves up to. It's just that the vertex is the easiest one to move. Once I get there, I know everything else goes just like it did before, so it's automatically every point is already moved up to. Does that make sense? Okay. So what about this one over here? Let's make the parent function that we're using the quadratic parent function, so x squared. And then for the one that we're moving, we'll make it be x plus 1 squared. So what's the parent function look like here? Yeah, u, like a parabola, right? So where is this one moving compared to its parent? Left 1. But it's the same shape, right? Okay, just move left 1. I didn't do a very good job of making it the same shape. You do a better job than I did, please. I went out too far on this one. Please forgive me. I mean, or not. It's really up to you. Everybody okay with that so far? Okay. So now we need the back. Yep, there's a back. Okay. So what have we not talked about yet?
Compression and stretch.
Compression and stretch. Okay. So we have y equals a times f of x. And we also have y equals f of bx. Are we doing rows again, or do you want to do columns this time? Okay, rows again. So what kind of change is this? How do you know it's a vertical change? Outside. Can we be a little bit more specific about what kind of change? Or?
A horizontal stretch.
No. Hold on. Vertical stretch or compression. Now, in your textbook, they say stretch or shrink.
Oh yeah, that was on there.
I'm sorry. When I learned it, I learned stretch and compression. So that's the word I kind of always go to, you know what I'm saying? But please know that shrink is the same as compression. Okay? So A was outside, so it's a vertical stretch or compression. Where's B? Inside, so it is a good. How do you know the difference whether it's a stretch or a compression?
If it's greater than 1 or less than, or between 1 and 0.
So if it's greater than 1 or between 1 and 0. So which one's which for A?
Greater than 1 is a stretch.
Okay, so if A is greater than 1, it is a stretch. Vertical stretch. We don't need to write that again because it's in the same column. Okay? And how do we know if it's a compression?
Between 1 and 0.
Okay, between 1 and 0 or between 0 and 1 is a compression. How do we know if it's a horizontal stretch? It's between 0 and 1, right? It's opposite of what we think because it's inside, right? So 0 is less than B is less than 1 is a stretch. And if it's a compression, then B is greater than 1. Any questions about that? All right, so let's add our example graphs. Let's make this first one the cubic parent function, x cubed. And our second one, f of x equals 4 times x cubed. So remember our parent function for a cubic looks like this. Remember that? I mean, kind of goes out more, sorry, like that. So when I stretch it vertically, like this way, it's going to get closer to the y-axis, isn't it? So it's going to be more like this. So let's make our example function on this one the cube root of x. And then let's make it the one that we're transformationing. That's not a word. Transforming. Okay, thank you. The cube root of 4x. We can make it a word. Okay, thanks. Transformationing. It's kind of like a gerund. So what's the parent function of a cube root look like? Like this. Now that's a 4, which makes it a compression, right? which means I'm going to squash it this way. So yeah, it's going to get like further away from the y-axis, right? Like that. Any questions about this? Now, guys, what's different in these notes I gave you today and the notes I gave you last week?
Really nothing.
Absolutely nothing, right? Except we drew a graph and we made this cool foldable thing, right? Okay? So, wait, so you're saying that I gave you exactly the same notes 2 different times to copy? Yeah. You remember more of what you write than what you see and what you hear. So now we've written it twice. Did that harm us in any way? No. Now we have this cool foldable to study with. Okay? Any questions?